Okay, these are the solutions to some addition reaction questions. So what is the product of the reaction between propene and steam? So propene, alkene with 3 carbons, that means there's going to be 6 hydrogens. It's always times 2. And steam is just gaseous water. So C3H6 plus H2O. Now, the nice thing about addition reactions is you simply add them together. So I'm going to add hydrogen, and really, I mean, you could just add them together. You could make C3H8O. It's not great because usually what we want to show is what kind of molecule it is afterwards, so what kind of functional group. And the thing about adding water is it kind of acts like it's H bonded to OH. So an H is going to add to one carbon and an OH is going to add to another. And so probably the better way to draw the product would be C3. The H number will go up to 7. That's the H adding. And then I also add on the OH. And now I can see that it looks like an alcohol. And it looks like some kind of propanol. Now, when you actually do this out, you've got propene, looks like this. And so if you think about it, the H could add to the first carbon and the OH could add to the second carbon. Or the OH could add to the first and the H could add to the second. So there's actually 2 different possible products here, but obviously the question has not gone into that much detail. And if you're just figuring out what the product of the reaction is, then the product is this. And you can say the product is propanol. The product could be propan 1-ol, product could be propan 2-ol, but it's hard, you don't have enough information to decide which it is. Write the chemical equation for the reaction between ethene and hydrogen. So ethene is 2 carbons, so C2H4 plus H2, and we're just going to add them, and we get C2H6. The condition needed is nickel. This is the hydrogenation reaction. It's a type of addition reaction. You could also call this reduction because you are adding hydrogen. Determine the structural formulas of the 2 possible products of the reaction between hydrogen chloride and but-1-ene. So but-1-ene has the double bond in between the 1 and the 2. And this is that thing where you've got the H could add here and the Cl here, and the Cl could add here and the H could add here. Now, it turns out that at the HL level, you should know that the major product is that the chlorine or whatever halogen it is going to add further inside the molecule, kind of more central, because of something about the mechanism that we haven't gotten to at this point. But those are the 2 products. So you're either going to make 2-chlorobutane. Notice it's no longer butene because when we add them, we get rid of that double bond. Or you can make 1-chlorobutane. Okay, number 4. The name of the following reaction and one use. Well, this is everybody's favorite. This is bromination. It is a type of addition reaction. And if you're just generically answering what kind of reaction it is, you could say addition. Bromination is a bit more specific, but oddly enough, sometimes not on the mark scheme. You might as well say both if you want to cover yourself. And the use is to distinguish alkanes versus alkenes. Alkenes will decolorize very quickly with bromine. Bromine is brown-red color, and as it reacts, it goes colorless. Alkanes will react with bromine very slowly, and so the color will stick around and won't decolorize. We're going to skip question 5 for now. I'm going to skip question 8 for right now, okay? And let's skip question 9 for right now. Let's now look at questions 6 and 7. 3-chloropropene acts as a monomer for a polymer. Draw the repeating unit. So the trick with polymers is you draw the double bond, okay, and it's propene. The key thing to do is to focus on the ene part. So here's the part of propene that's the ene. I need to draw a 3rd carbon somewhere because it's prop. So I can, off of any one of these 4 bonds I've drawn, I could draw that next carbon. I'm just going to draw it up here and if I think about it, would have 3 hydrogens off of it. Now, I've also been told that I have a 3-chloro. Well, when we number, the functional group, in this case, the ene part, always gets the lowest number. So that means this must be the first carbon, that's the second carbon, and this is the third carbon. Let me do that in a different number, or a different color, sorry. So 1, 2, 3, because if I did it the other way, then this would be the first carbon, that would be the second, and this would be the third, and I'd end up with prop-2-ene, right? There'd have to be a 2 in front of the ene. I don't see that in the name, therefore that's not the numbering system. So this is the third carbon over here, the one sticking off, and I can see that the chlorine is on that one, so I have to draw the chlorine over here. Okay, the rest would be H's. So the hard part is just interpreting that name. It's a kind of a tricky structure. So you can also think about this in a more condensed way. So like these are the H's. This one is a CH2Cl, and this one is an H. So this is the same molecule, but I just kind of drew it more condensed. Now, when you draw the repeating unit, all that happens is you get rid of that double bond. So I'm going to redraw this thing. You take the same 4 things that were on it before. Usually you draw it more straight up and down to allow room for these bonds, which are the sort of extension bonds. So now I've drawn the repeating unit. So the hard part is figuring out the monomer and actually just drawing the structure of 3-chloropropene. Once you've done that, getting the repeating unit just is taking away the double bond and adding extension bonds out on either side. Okay, the other way that they ask about polymers is they show you a section. Okay, the key is that every repeating unit comes from the C to C double bond, the alkenyl group. So you go here and you cut this molecule up into 2 carbon sections. These are the units. Okay, so that's a repeating unit, that's a second one, and that's a third one. And it's just because I'm looking for 2 carbons. Okay, so now I reverse the process that I did up above, and so I'm going to redraw it. So this is what I see repeating. Okay, and instead of the bonds on either side that were connecting these units, I get rid of those and I add back the double bond. And that, therefore, is the monomer. So I can undo what they've shown me on the left as the polymer, and I can figure out what the starting monomer must have been.